So I guess while you're doing that, maybe I can describe a little bit about how I got here, how this presentation kind of came to be, and back in the mid '90s when we were performance testing commercial applications, there was client server, right? We had database applications, things that were just an Oracle client and a database backend, and testing those systems was pretty simple, and then other protocols, other architectures, pretty much the same thing. And as the web developed, we kind of thought we left that architecture behind, and web applications grew, I think, out of a necessity for a number of things. We didn't have the internet pipes that we have today. We didn't have really good browser technology for a long time, right? I mean, we're just really coming into this. The last decade has been bringing forth pretty substantial improvements in the browser technology, massive improvements in the data pipes that customers have, and so that web architecture was really a way, and I mean, basically speaking, web tier, app tier, database tier, and maybe you have messaging and other stuff in there too, but that distributed architecture brought forth the performance power, the grunt, if you will, to provide a user experience that was acceptable, and that's been the way it's been for quite a long time, except for about the last 10 years, about 2009, 2008, we've seen some things happening in the marketplace, like Node.js, just to use that as an example. The shift in the ability to architect applications in a very different way has happened, and also mobile happened, right? So now we have this idea of smart devices, we have mobile devices, and originally we were seeing people shoehorning standard websites, basically just the HTTP constructs, into frameworks that were that you could provision onto a mobile device. So Cordova, for instance, it was just HTML framework, put it in a mobile device. It was the same website, and then we had reactive technology come out and things like that. And then as mobile devices became kind of the center of the universe in a lot of ways, they became thick clients again. And now what I'm seeing over the past 5-6 years is the shift of web design to that mobile application sort of construct, where now the browser is containing the application just like a mobile device would. And so there's a lot of parallels there. It's funny, we're kind of going in this concentric pattern around some core of technology, and so what I've seen happen, and what I wanted to talk about, and so this presentation is really constructed around a question, which is, especially as a service provider, when we're trying to performance test, like Volk does a lot of managed testing, so customers hire us to test their sites for them, and as you might imagine, as a contractor, consultant, an outside person coming in to do that kind of work, we have to scope these things. We have to come up with timelines, and we have to work toward those timelines, and we're constrained by costs and things like that. And so when you run into a situation like this where an application is contained inside the browser, and I guess maybe we could just go forward a slide here, Henrik, sorry, again, thank you. As we move into this space, the task of creating performance testing scripts, and that's all I'm really going to focus on. This isn't talking about functional tests. This isn't talking about necessarily, like I think you said, talking about measurements specifically. How do we measure these things? That wasn't really the key here, but it's certainly a factor of it. But what I wanted to talk about is the challenge that's presented to the practitioner, whether you're an employee of a company that's using tools from various vendors to do performance testing, or whether you're a consultant, doing this for a living, identifying the challenges that are presented by these websites is really key, because there's how you approach testing this is complex. It's complex. You have to make some decisions, and that's really the goal here, is to talk about those things. And I kind of have an open-ended question, which is, how do you test these things? And I have some ideas, and I'll propose some ideas. So, we kind of thought this client-server simplistic web application design was gone, right? But it's not, and no longer are are developers afraid of putting content in the browser. They're loading the heck out of the browser, megabytes worth of content, and it's kind of challenging, And at SOSTA, one of the things that SOSTA was really good at, and what their focus was the millisecond. Taking every millisecond seriously and not taking it for granted. And guys like Steve Sauter at Yahoo, who put their whole careers into analyzing and breaking down the components of where's the latency in the chain from the user request to the backend server response times, and then delivering that content, and how do you strip every unnecessary millisecond out of that interaction to speed up the user's experience. And the fight for a while there in the mid 2000s was winning at the browser level. What could you present, in the concept of above the fold and below the fold? I think Steve Sauter kind of coined that expression, and it talked about, if the user's perception of the page being complete. And that was a huge battleground. And that's what we were fighting for. And when we would load test, that's what we were concerned about. How could, what was the perception of the content that was coming back from the servers? Was it enough? Was it fast enough? Was it complete? Et cetera. So for a long time, we've kind of been trained to focus on that thing. And then what's happened now, if you could go to the next slide, I like to use GTmetrix. Thank you, PerfBytes, for pushing this, because it's come in really handy. I like to use this particular service to monitor some of my customers' websites. And this customer, who shall remain nameless, routinely gets this grade. And we've performance tested for these people. And what you're seeing here is 8 megabytes effectively of content. And this is just the home page. This has nothing to do with adding things to the cart or the experience that they get further down the process. It takes 12 and a half seconds to load this web page. It's crazy, but they're not unique. And, we've seen other sites that are very, very similar. And when you start to, so for instance, if you're a contractor and you're trying to sell a web test or load testing service, what you have to do to test this site is dramatically different than what you would have to do to test a standard HTTP web-based, 3-tier type architecture, right? Here you're dealing with a lot of stuff. There's a lot going on here: JSON, jQuery, big XML payloads, and I'll kind of break that down a little bit as we go further. So if you could go forward, Henrik. Thank you. So, we've had in the past various web frameworks that have presented their own challenges. Siebel, PeopleSoft, SAP tend to be more difficult. Even .NET, right? You got a lot of view state variables. You got a lot of stuff you got to correlate to make these your scripts dynamic and usable and reusable over time. What I'm describing today is not necessarily this kind of SPA or single page application structure. There's certainly an aspect to it that is kind of an SPA aspect. It's really born of all the Ajax and some of that Web 2.0, which I kind of have disdain for that term. But what came of that was basically pushing more stuff back into the browser, from the data center into the browser, tons of JavaScript, tons of of objects and data and business logic, right? So one customer we've tested with recently, this was actually a deployed application. Every user interaction at the browser had to authenticate and made a direct DynamoDB call out to Amazon. Every single interaction, and we used Neoload for that. It was, thank God, it was much easier to handle than it would have been in other platforms. But for instance, where we would normally expect to get about 1,000 virtual users from a load generator, we could get 70 because of the JavaScript and the workload that was put into trying to reproduce those user actions to that backend server. So from a sizing and a timeline estimation perspective, that kind of curveball, if you're not expecting that when you go into a project or when you're handed an application to test, that's huge. That blows your timeline way out the door because you didn't expect to have to deal with any of that. And so, some of the previous conversations, like I think I came in during the EMEA section for the two Brunos, and there was a conversation there about keep your script small, avoid these really, really long, complex business processes, and that's certainly an aspect of how to contain your workload. But as we start to look and we unpeel this very complex onion of these complex browser-based business applications, we're going to have to make some hard decisions. Are we going to chase that rabbit down the hole of trying to reproduce end user click path type interactions with the server in an application that is that we maybe can't capture all those interactions with? And my upcoming slides will delve a little bit deeper into that. And I had already kind of mentioned these other points. So if you could go forward, Henrik, please. Yeah, next one. So identifying. This has been a challenge. This has been on my plate for a couple of years. I'm frustrated to say. I've wanted a tool that I could point at a customer's website and say, warn me about these technologies that are difficult to deal with, so I can. It's kind of a lazy approach, right? I want you to just tell me about it. I want to understand. Does it meet the fingerprint of some of these architectural components? Does it have these big payloads? Does it have jQuery? Does it have a lot of these in-browser components that we've come to know can cause problems, right? Because again, most testing tools, most performance testing tools, deal with what I would call a send expect type of model. We send a request, we expect a response back. User clicks a button, it sends a request, we get a response back. Ajax messes with that a little bit, right? But these apps don't do that. They may have a component of it, like setting up a session. You'll have a pretty standard interaction, and I'll talk about that on the next slide, I think. But how do you start to peel that away? And I've tried to use tools like BuiltWith. And BuiltWith, if you haven't used that, is a very handy little tool. However, it doesn't deal with authentication. It doesn't deal, you're basically pointing it at the home page of a website. And so you can find out a lot about that home page, but a lot of times, as any seasoned performance tester will tell you, a lot of your problems come much further down the path, right? When you're dealing with abandonment issues, or you're dealing with just checkout, or you're dealing with dynamic, like say you're dealing, it's a product-based website and there's a lot of variations. You can choose colors and sizes and things like that. Just dealing with those dynamics can be rather challenging. But these sites will contain all of that activity within a JavaScript app in the browser, and they may click 10, 15, 20 times, and the server will never get a request. So not only how do you measure that, there's nothing to measure, so how do you test that? And that's the path we're headed down right now, kind of intellectually. Is we've identified this challenge, and now I kind of want to talk about the components of it and what do I think we can do to make some headway here. So if you can go to the next slide. Thank you. And this is very simplistic, but vertical timeline from top to bottom, kind of maybe an Ajax-y type of application, right? You have some interaction. The user is getting or sending requests to the server. The server's responding. Maybe it's a form or something like that. You might go to another page where you have like a predictive search mechanism. And so for years, we've dealt with this in the web. And, one of the ways that we typically deal with it is, if we have like a file full of search terms, we can load that up into an array and then just spin on it, right? We can just fire off those Ajax requests, like the first 5 or something like that, and then we submit the request. There are ways to deal with it, and we've all probably come up with our own ways to do it. And then ultimately, maybe at a site like this, there's a video or there's something, and there's a large amount of video payload or something like that. We know how to deal with those things too. We can, download these big blobs, and we can look at, MD5 hashes or something like that. We can quantify both the payload, the time it took to get it, and we can validate it. That stuff's not a big deal. It's a little time consuming, right? But not a big deal. If you can go to the next slide, Henrik. So these pages tend to have a much different fingerprint, which is, very, very large payloads. I've already really talked about this, but a lot of content, a lot of constructs inside the browser. And then also, if you're doing a standard recording, so we, with our tools that we have at hand, be it JMeter, even like a load runner or NeoLoad, when you do a recording, you're expecting to see certain things, right? You're interacting with the application, pardon me, and you expect to see server requests, and I would call these couplets, action, reaction. We expect to see these things, and in a thick app like this, you don't all the time. You'll have huge amounts of interaction, perhaps dozens of things you can do that don't even fire off a request to the server. And those are the red flags. Those are the types of things you have to identify. And sometimes, again, you have to get down in the app to expose this thing and to see it, right? Let's go forward a slide, please. And again, just to kind of illustrate what I just said, same idea. Got a vertical timeline from top to bottom. You may see a form, you may see kind of a standard HTML handshake between the client and the server, and then all hell breaks loose. All of a sudden, you're getting 3 megabyte, like one application we just looked at. It's a custom interior design web-based application, and so they're loading models of things like living rooms and kitchens and home spaces, and you can customize all this stuff. You can change the colors, you can change the styles, and so all that content comes down to the browser. It's got a 3D modeling engine, and the user lives in that space until they're done. And if, for instance, if they didn't customize that, if they just took the standard template with everything that downloaded to it, between the time that occurred to the time that they saved their project, you wouldn't see any substantial server traffic. You wouldn't see any requests. And in fact, in this particular application, when the user gets to the end of that path and they say, I want to save my project, it saves from the JavaScript to their local drive. It doesn't even go to the server. And likewise, if they reopen an existing project, that's a computer to browser function. It's not a computer to server function or vice versa. So it breaks your brain a little bit when you're trying to figure out, okay, now, we talked about this a little bit earlier before the US session, and it was about what I refer to as kind of fanciful thinking sometimes on the part of a customer. And the example I used was the board of directors for this company wanted to see 1,000 physical mobile devices engaging with their site as part of the performance test. And that's just, it's possible. Is it wise, right? So we have to kind of find ways to meet the customer's desires, to meet their needs, to figure out, to kind of strip away some of the smoke and get down to the core of the issue. And with this kind of website, again, we're not battling milliseconds. When it's taken 12.6 seconds to just load your home page and you've transferred over 8 meg, a millisecond doesn't seem to matter. The customer's not concerned with that. What are they concerned with, right? What now are we actually testing? And this is kind of getting to the crux of the problem. And so if you are not going to focus on an end user click path, that means you don't have to reverse engineer the application in your testing scripts, which is a huge effort. You could do it, just like the 1,000 mobile devices. You could do it. Should you do it? The time, the effort, the fragility, these things are going to break easily. I go back to Bruno's comments about, don't create this massive script with 20 steps or 30 steps. Keep it simple. Keep it to the core of what's going on between the client, in this case the browser, and the server. Can we go to the next slide, please? Okay. So in this send expect tool-based model, it's really difficult to deal with these heavily loaded web pages. And some vendors had some tools. There's still a couple out there, right? There's TrueClient. Hendrik mentioned that. I was at Keynote, and Keynote had a product, a web testing product that ran in the browser. It was not scalable, and that's what ultimately killed it. Dynatrace had a product, right? They had the Gomez synthetics tool. They had a web load test product that was engineered around that Gomez tool. It served this client base. And when Dynatrace and Keynote respectively killed those products in favor of a traditional web-based client-server type testing product, it created a big problem for us. I'm speaking as a former practitioner in the Dynatrace world. We had to try to bring customers over that were familiar with and accustomed to testing browser-based scenarios with a client-server headless testing tool. And so that's when I started really down this journey of trying to grapple with this problem that gets presented from time to time. And ultimately, I think, can we go to the next slide, please? I think what we have to do is really look at these applications from a pure workload perspective, from the client to the server. And I refer to it as a taxonomic approach. Understand it kind of like a web services testing, right? If I make a request and the server responds with 10 seconds worth of content, megabytes and megabytes of content, that's fine. That's one type of transaction. And if the customer requests a customization, let's go back to that 3D modeling scenario. They request a customization. They want the silver cabinets instead of the wood grain cabinets, right? What does that generate? And break it down into those actions, and then the burden is on the test designer to get the real world data to back those things up, right? What are we modeling? Are we going to model a peak load based on what? And again, it's probably not milliseconds that they're concerned with. At this point, you're probably dealing with a capacity-related issue. Where is that content coming from? Is it edge delivered? Is it origin delivered? How big is the pipe? How many requests per second could be made? So there's a lot of questions you can answer, and you could certainly test the heck out of this thing, but you probably would not do it trying to create an end-to-end user workflow like you would in a web-based application. And again, you can do it. We certainly have applied a lot of power and a lot of intellectual knowledge and a lot of time and effort to scripting a couple applications like this. But I got to tell you, it's a losing proposition because the scripts are fragile. It's an unnecessary amount of work. Again, kind of back to Bruno's point, keep it simple. What are you actually testing, and how can you guide the customer or guide the team that's trying to performance test this application? How can you guide their efforts to get the most out of this, the most benefit for the least amount of effort and cost, right? Could we go to the next script? Or next page, sorry. So again, the architecture, the landscape has changed. We've got now these tools like Node.js in the development side of the world, and the testing tools have not kept up with this. Neoload is fantastic as a tool as it is, as easy it is to use. It's still, when you get put into a situation like this, you have the same struggle that you have with any other tool. How do I script this? How do I create a load test that's realistic, that's reproducible, that has got some shelf life to it? And by that I mean, it doesn't. All the scripts don't break next week. Maybe they do. Maybe they don't. But we used to have a concept. I did back in the 90s that test scripts were like tissue paper. They were just single-use things for me as far as I cared. I wasn't invested in them. I would create them quickly. We could test and we could script anything, and if it changed next week, it didn't really matter. Well, that paradigm has been lost for some time, I think, because of the complexities of dealing with a lot of these technologies and a lot of these complex frameworks. We're putting more and more effort into the scripts. We're putting more effort into reproducing some of this thick client functionality, and therefore, your natural reaction is to try to preserve that, and it presents a challenge, that's for sure. So, just kind of looking through the bullet points here. Doing a recording is the best way to identify these sites. Like I said, you can't use built with. It won't tell you enough. It'll tell you some things, but not enough. You won't really know, as in my timeline diagram, the homepage may just be a standard page. It may be like that, the GT metrics page I showed you. It may be massive. It may just tell you right out of the gate that, whoa, something abnormal or something out of the ordinary is happening. But most of the time, you're not going to find these challenges until you get a little bit deeper down and you've gone, past the authentication phase. In a lot of cases, approaching these at a taxonomic workload perspective is probably the best way. It just is going to have to be until we have scalable browser, like headless browser-based testing en masse, where we can run thousands of virtual users. It's just not a reality today. It will be. Somebody's going to solve that problem. Hopefully it's Neodis, and bring browser-based testing to the masses, because it's going to solve a lot of these problems, I think. But really, you're looking at ways to test the server's capacity to deliver all this payload, and so that's really the focus of the test, and that's what the customer should be convinced of, I guess, would be the right way. And I think a lot of times, if you work with an architect and they comprehend exactly what you're talking about, you can get them on your side, so to speak. You can, as far as being a technical advocate of how to approach the testing. And again, Neoload, Load Runner, BlazeMeter, whatever, all of these tools can handle these web pages, these types of web applications. But it's just a matter of how much time and effort do you want to put into it. And again, breaking down, where's the content coming from? Is it coming from an edge server, or is that what you're testing? Probably not. You're probably testing your origin servers. You're testing things within your domain that you can control. So you have to really do a lot of work to break all that content down, break down the workload, figure out, what are the variances for the user community? What are they doing? What kind of work are they generating? And then how do you represent that in a load testing script? And then build a scenario that's representative as well, which ultimately will come down to, transactions of a type per second, per minute, whatever that interval might be. And I think that's the end of the slide deck. Yep. So I guess again, it's kind of an open-ended presentation. It's I like to air my thoughts, air as in put them out in sunlight for people to see before they're fully cooked. So this presentation really wasn't a conclusive presentation. It was more of a conversation about this challenge and to put it out there for folks to comment about, and maybe you have ideas of your own that you can bring to the table as well. But I guess we'll open it up for Q&A.
So I think thanks, Brian. I think your presentation was make a lot of sense because obviously what I used to do. I mean, when I was heavily involved in scripting, so even streaming, adaptive streaming stuff, I was my main game, I would say, was to open the Chrome developer tool and look at how it's been loaded, and figure out,
Exactly.
Okay, so this resource is like going and pulling, like, okay, so I'm going to reproduce that. So I was doing like a scripting like this, which, like you mentioned, you make sense. I mean, it's always possible to design this browser logic within the load testing solution that are protocol based, but the design effort is huge, and that's the first thing. And the second step is, okay, I've done it once, woohoo, I'm happy, but okay, next week I'm going to retest the new release, and then suddenly you say, oh no, I'm not going to go to that path again, which is going to consume again 2 days just to design. Yeah, so I think it's a big challenge for everyone. There is many solutions that will make the rendering and interacting with a real browser, but I think my main concern, I mean, for a load testing perspective, in terms of if you have to do 5 million users, concurrent users on a solution that drives a real DOM or a real browser, then the footprint of a user is too huge. So then instead of investing in designing, you're investing in hardware. So that's always the balance. And I think we have a pain we have to figure out of that. So I think we have the honor to have Todd connected here, and he's been working many. I mean, probably most of the attendees knows Todd, because he's been involved in many different organizations. So Todd, what is your feedback on that? And do you have any questions to Brian?
I think we probably have more questions for Brian than we have time for. But I guess as Brian, you see a lot of the different, I know some of the last bits of the conversations around fat clients and performance engineering and testing of those. What are some of the, I guess, most challenging fat clients that you've come up against over the last, say, 6 months to a year? Because the thing that I find is sometimes those vendors want the feedback of, what is it that we as performance engineers have found and limitations, and again, are they changing object names so frequently that it makes it impossible? Are there different standards that inefficiencies in the way that they've built their vendor-based products are just inefficient in the way that we found it? Or is this more just, more custom fat client, two-tier type things coming back to bite us?
Yeah, unfortunately, I would say the bulk of the customers that we've run into of this type, and one of them was an automotive manufacturer, and it was extremely difficult to try to script. And when we tried to explain why, they didn't care, and they just wanted, they were a customer of one of the older web-based testing tools, browser-based testing tools, and they didn't care about the technical challenges. And so that's something you're always going to potentially run into, right? Is that the customer just wants what they want, and it's your job to just overcome whatever challenges there are. But to your question, I think in almost all the cases, these have been e-commerce sites of some sort, and they just have a very rich, a very very creative marketing department, and that creativity comes through with the rich content in the browser. And this is how the technical teams have solved the problem to present that vision, and it's just not testable. Basically, we've all run into that before.
Yeah. What do you see in your crystal ball, Brian? As I heard a little bit of it, of kind of some of the headless capabilities and things like that would be outstanding to bring to market. Are there other things that, as you look in your crystal ball, you would say, man, if we could have something like this, this would really help all of us out in the marketplace?
Yeah, I probably it's going to be, at least for this type of customer, this type of website, it's going to be a highly scalable web browser based testing product, or an engine at least that can load and parse and run JavaScript. And so we all know what the challenges are there, right? Lots of CPU, lots of memory. It's not scalable today, but it's going to come. Somebody will figure it out, and it's going to be some kind of a virtualized platform where you can just spin up 1,000 of these tiny little browser VMs on a server in Amazon, and it's not going to be a big deal. And but we're probably 5-10 years from that, I think.
I mean, we have two partners in Europe that has worked on this headless technology. One of them is, by the way, open source, so they're using that for the APM product. So they shared the technology. It's working very well. The only thing is it requires to make the load generator architecture, you need to install those browsers. And it means if you need to have, let's say, I need to do extreme load testing involving 600 machines, then suddenly you come to a challenge where you have to install all those requirements. So you also have that. So it resolves one point, but sometimes it's bringing another challenge. So I think now we sort of have the picture, but we don't have the full architecture yet designed to resolve that big pain, I think.
Yeah, and I what strikes me is that both Chrome and Firefox have a virtualization engine as part of their architecture, and I think that therein lies the solution to this problem. And I think it's just going to be either some heavy duty work done by those vendors, or by the open source community that can harness that power of this virtualizable browser engine and figuring out a way to scale it up. But yeah, there's huge challenges, and it's not going to solve every problem, right? There's going to be IE specific stuff, or whatever you call it today. There's going to be Firefox issues and Safari issues and things like that. But at least for the bulk, honestly, when Dynatrace and Keynote decided to kill their web-based testing tools, they left a lot of customers sitting on the table, because these people don't care about traditional web testing. They wanted browser-based testing, and they tended to be smaller deals. They tended to be kind of boutique companies, but there are a lot of customers out there that are asking for this sort of thing. So that's kind of where I see it going. It's not going to solve every problem, but it can solve some of them.
Yeah. So I guess we have to work on that.
Yeah.
And shortly. All right. Any on the questions, Todd? I'm just going to look at the Q&A if there's questions from the audience. Nope. There's a lot of chat going on. Let me check.
Definitely great to share the microphone with you, Brian. And I was noticing Mark Tomlinson's blue hair. I think it's getting bluer. Mine's getting grayer. And I guess the color you had prior too, but
it used to be there.
So it's always fun to poke fun at each other.
Yeah. Well, I know, Todd, we've probably circled the same planet, so to speak, for many, many years. I've heard your name, and we just never seem to be in the same building at the same time, but we know all the same people, so good times.
It's absolutely a pleasure, and I think, Henrik, that's one of the things that I've enjoyed most about being part of the the Otis Performance Advisory Council is from the first invitation and all of us showing up in Scotland back in November. I mean, to have all of us in the same castle for 2 days was fabulous. So to be able to do the same thing in a virtual setting, I think is equally as fantastic. But I can't lie, I'm very much looking forward to Paris. So.
So it's not going to be Paris. It's going to be south down in a location where you have snow. It's going to be in France for sure, but
Okay.
it's going to be in winter with snow.
Lovely.
Yeah, we definitely want to reproduce that because we really like the all the interaction we had with the session, of course, but after the session as well, because there is
Yeah.
a lot of networking going on, and then it's always cool that we see that we have PACE members afterwards that interacts and work together. So that's the idea of building that type of events.
Yeah,
All right.
like Brian was highlighting, we've all worked together for so many years, and finally we're able to sit together.
Yeah, for sure.
Yes.
Well, thanks, guys. Appreciate it.
So, Brian, I would like to thank you for this presentation. Thank you to take the time to build that content. I really appreciate as well the fact that you've been connecting this afternoon for European speakers. So thank you, Brian. That's really awesome to have you on board.
Well, thank you. I appreciate the invite. Cheers, guys.